A man of mass 75 kilograms is standing on a uniform horizontal wooden plank, weight 250 newtons, which is put over a stream spanning 3 meters. Find the reaction forces exerted on each end of the plank. Well, here and here there will be a reaction force to the plank resting on the bank of the stream. Okay, so we've got a man here who is 0.75 meters from this end, and we know the length of this plank is 3 meters. Okay, so what you've got to do is draw a clear force diagram of the forces acting on the plank. So here we have the plank. We have one reaction force, which we're going to call R1 newtons, and B, second reaction force, which we're going to call R2 newtons. We know that the man is standing 0.5 meters from the bank here, so they've got a weight of 75 G newtons, because we're told his mass is 75, and the plank itself, the weight will be acting at the center, which is 250 newtons, so that will be 1.5 meters, because the total length of the plank is 3 meters. Also, we have a reaction here, R2 newtons acting at B, which corresponds to this point here. So point A is here and point B is here. So having drawn the diagram, we can the plank will be in equilibrium, so both the resultant force and the total moment must be equal to 0. So if we take moments about point A, now you don't have to use point A, you could use point B. Okay, so taking moments about point A, well, there's nothing here from this force here, so this will just be 0 times R1, so we won't worry about that. So let's just do the anti-clockwise one. So this is going to be the ones that try to make the plank move in an anti-clockwise moment. So that's going to just be this length here times this. Remember, the force must be at perpendicular to the line acting from the point. So it's going to be 3R2. And then in the clockwise direction, we're going to have 0.75 times 75G newtons. So minus 0.75 times 75G minus this one as well, which is going to be 1.5, because the distance here is 1.5 times 250, and that's equal to 0. So on my calculator, if I work this bit out, I'm going to have 3R2 minus 926.25 is equal to 0, taking G to be 9.8, and therefore R2 will be 926.25 divided by 3, which is 308.75 newtons. Right, in order to find R1, we could do the same, just take moments about B, or we could just resolve the forces vertically, which I'm going to do, but either method will work. So resolving the forces vertically, upwards we've got R1 and R2, but downwards we've got 75G minus 250, and that must be equal to 0. We already know that R2 is equal to this, so we can say that R1 plus 308.75 minus 75G minus 250 is equal to 0. So it's going to give me R1 minus 676.25 is equal to 0, and therefore R1 will be 676.25 newtons. So the force here will be 676.25 newtons, and the force here will be 308.75 newtons. So this has been a video to show you how to find the reaction forces of a plank sat on going over a stream with a man on it. I hope you've understood, and I thank you very much for watching.